test. Okay, I finally got myself set up, and so give me a couple minutes to make my key. You can enjoy this quiz for a little bit longer. Actually, plenty of time. I just realized there's not a big space here. If you need to use the back for your table, if you can't write really small, sorry about that. I just trying to make my table and it's kind of hard.
No, next time, like double sticker.
Double sticker.
Thanks.
I forgot to bring my stickers. If you want a sticker, you can come to my office, or you can wait till next time. Either way is fine. I have a whole stack of them. All right, if you're done, it looks like some of you are already playing Clash Royale. So if you are done, feel free to filter your things over to the middle. I'll come get it in just a minute. If you aren't done, take your time, but try to hurry up. Wow, good job. I guess you guys got it first, right? So front row, super fast. Nice work. Wow. Nice. Nice. Oh, thank you. I forgot to come get them. I appreciate that. Thank you. Wow. Wow. I sold you guys short. I thought that you would want to savor this experience more, but you're quicker than I thought. Okay, or maybe I'm just slower than I thought. All right, let's take a look at the at what I have. Hopefully, I haven't checked. Usually, I'll scan through yours to see if I match up with the majority, but we'll see what I did. Okay, so for the first one, we have the age in years of a sample. So we have a sample. So keep that in mind. Sample of 5 dogs, randomly chosen from the dog shelter. And so add them up, divide by 5. Came out nicely, didn't it? 8, I hope. So I'll do this. I'll try to do the best to make it come out relatively nicely when I have you do calculations, because I know it's a pain to have a number like 5.37214. So take that, and subtract it from each of these. We get those numbers, and then we're going to square each of those, add them up, got 200. And then here's where we might have differences. This is a sample, and because it's a sample, you use the sample standard deviation formula, not the population. Sample formula, divide by 1 less than the number of data. If you divide it by 5, it's okay. I'm not going to drop the hammer on you. It'll just be a slightly different answer. You'll have 40 instead of 50 for your variance. And then the standard deviation is the square root of that. So 7.1 or 5 radical 2. Anything? Questions, concerns? So yeah, so if you had 40 instead of 50, like I said, I'll take off a point or two, but I'll be like, oh, look at that. It's fine. I mean, I'm glad that you were able to do the rest. That's the thing that's impressive. As far as z-scores, so we did this last time. Hopefully I did this calculation right. Frank, you're comparing his incredible 455-pound bench press with the rest of his team, 455 minus 385, and then you divide by the standard deviation just so that you know how unusual Frank is. So he's 2.66 above average, which is pretty unusual. But then you look at Hank. Hank is even more impressive. Compared to his team, he's 4 standard deviations above average. So Hank is the winner if you're just saying who's most unusual compared to the team. But the z-score is the more important thing, is to remember that let me write this down. If you're saying z-score, how did you do that? Okay, so here is the z-score formula. Z is equal to the observation minus the mean over the standard deviation. And so it's just how many standard deviations are you above or below average? Yeah, what do you think, Oz? Ah, it is, isn't it? I guess I need to get my head checked. I will do that after class. Maybe I'll just I didn't bring any additional caffeine, so I'll blame it on that. Yeah, I did all this. So I made that wrong, but look, I got that one right. I added all those numbers. Okay, well, got to take the victories where I have them. Anything else? Thank you. All right, so then the last one, largest standard deviation is the one where everything's the most spread out. And so you might say, well, this is just, well, it's not really. There's only a few things that are kind of far away from the middle, whereas here it's like all of this stuff, way spread out. So that one's the largest standard deviation. The smallest standard deviation, you could probably make an argument that B is the smallest. I'll accept that, but I'm pretty sure that if I actually put the numbers, like here you have 1, 2, 3, you have 10 twos, 1, 1, 2 threes, 1, 4. If you put those numbers into Excel and compute standard deviation, I'm pretty sure this is going to be smaller than that. In fact, no, I'm not pretty, I know. This is the smallest. That one is a little bit larger, but I will accept either A or B just because they both would indicate that you understand that standard deviation just indicates how spread out. Those are not as spread out. This one's kind of in the middle, and this one's the most, everything's everywhere. It's all spread out. Oh, and that's it. Yeah, that's it. Good. All right. So we're doing two things today, and you have two homeworks for Friday. One of them is super easy. It's gonna take no time. Well, it'll take some time, but it won't take much effort. So let me do that one first. In fact, we could do that one in relation to, let's delete all this, in relation to that, what we're looking at up there. So let's just pull this over. You don't need your Excel, don't worry. This is gonna just take a minute. So let's go back up to this. So take a look at that. And I said I could compute the standard deviation for that on Excel. And that's what I'll do. Let's go ahead and compute that standard deviation. And first of all, I need the data. So if you have data, and then I'll explain what 5, 6, 7, 8, 9, 10. And I'll explain what the homework is going to look like in a bit. Let's see, there's 2 3s and a 4. Okay, so there's my data. I know it's hard to see. There it is in a big long column. So on the homework, what you're going to be doing is you're going to be doing something very similar to today's homework. So that's why I thought, we can just gloss over this and you can do it. You're going to do something very similar. That is, identify when you're going to be using a population standard deviation and when you'll use a sample standard deviation. So hopefully you've got that sort of settled now. But then in addition to that, you're going to take the data, and you know how to do this, but if you need help, come by tomorrow. But you'll take the data out of Newton, put it into Excel, and then just compute that standard deviation. And here's how you do it. If this is a population, then you'll use this formula. So here, I'll just put this up. It's really simple because, is that as far as it goes, zoomed in? Yeah, I guess so. I guess I could, hold on a sec. Can I do that? No? Oh, yeah, there. It's nice and big now. Well, it's bigger. Okay, so when you type STDEV, even though you can't quite see it from the back, you'll notice that Excel gives you the nice little cheat sheet. I love that. It didn't used to do this 20 years ago. So this is so nice because I'd always have to say, do this, that, and those. I don't remember. So this, it just says, hey, I think you want to do one of those. And so it's either going to be one of these top two. Let me explain the difference. The top one, STDEV.P, I'll bet you can guess, that's the population standard deviation. STDEV.S is the sample standard deviation. I'll do both of them for this data set just to show you the difference. There's not much of a difference. So, but then I'll do .P first. And then I just go back here and highlight all of my data, close parentheses, hit enter, and there it is. So that's the standard deviation using the population formula. Now let's just do the same thing, equals STDEV.S. So the sample standard deviation, we'll do the same thing, close parentheses, hit enter, and there it is. So you see, there's not a big difference. In fact, the larger your sample size, the less of a difference there's going to be. However, despite that fact, Newton will want you to use the correct one. So read the problem carefully. If it says you have a sample of dogs coming from the dog shelter, then use the sample standard deviation. If it says that you have the entire, like we could go to the dog shelter and we could sample we could have the entire dog shelter, all the dogs, then that would be a population. So that's pretty much it. Okay, that's step one. The second thing is much more fun for me. I don't know if it'll be fun for you because we get to talk about probabilities. And if we have time, it's still going like that. Just a minute. There we go. And if we have time, we have some statistics you can use. So that's always fun when I have that sort of thing. So I think you already know what probability means. You're probably familiar with the idea of a probability. And so because of that, I think you probably can handle these sorts of questions. what's the probability that it will rain today or precipitate in any way? Take a guess. Take a guess. Then what's the probability that you will get an A in this class? That's another thing that we could talk about, and you could take a guess at that. You don't have to tell your friends if you don't want to. You might say my probability is 100%, or maybe you'd think it's 0. I don't think it's 0 for anyone, at least not yet. After spring break, I might change my mind. What's the probability that you will win the Powerball lottery, or whatever the current lottery is these days? And then what's the probability that you will die during the next year? I know you think I'm so morbid, all this talk of cancer and death. Well, it's a thing that we can talk about, I guess. I'm not scared. So anyway, take a guess. I will show you the answers. I actually can tell you your probability of dying during the next year. Well, at least according to the CDC life tables. Ironic that they call them life tables, but there it is. First off, theoretical versus relative frequency. So a theoretical probability is the thing that you learned back in 7th grade. Let me prove that you've learned it. If I roll a 6-sided die, I wish I had brought, oh, did I? Let me see. I sometimes leave my toys over here. No. Oh, well. You can imagine what I'm talking about there. Is a 6-sided die. I'll draw one just in case. So here is my 6-sided die. It has the numbers 1 through 6 printed on it. So it's got 1, 2, 3, 4, 5, 6. What is the probability that if I roll this, what's the probability of getting a 3, for example? So I'll bet you know this. I know, oh, I got to pull up my attendance anyway. Give me a sec. I'm not going to do the attendance yet, but I'll at least get it up here so that I remember to do it before I leave. Here it is, and then that'll give me a chance to randomize. Come on, waiting. Okay, random student, Joshua. Yeah, there you are. Sorry, you moved during the, well, yeah. What is the probability of getting a 3 on a 6-sided die? 1/6? How did you do that? You don't know. There's one possibility of getting a 3 because on that die, we've all, well, most of us have probably played with dice. There's a 3 on there somewhere, and there are 6 total chances. Yeah, that's it. Very nice. So that is a theoretical probability. A relative probability or a relative frequency probability, that's more like a statistical thing where I ask, if I ask someone at random if they drive a truck, for example, I would base that on the statistics or the relative frequency of this class. Yeah, I should have had my data here, but that's the idea. So relative frequency theoretical is this sort of thing. Relative frequency, you could think of it as based on data. So if you have some data, like for example, during the past week, maybe, I woke up at 3 a.m. on 4 of the 7 nights. It's a thing that happens, by the way, to guys, especially in their 40s and 50s. So get prepared. Anyway, so let's say that I woke up on 4 of the 7 nights at 3 a.m. Always 3 a.m. Why 3 a.m.? I don't know why. But so based on that data, I would say that my probability of waking up at 3 a.m. tonight is 4 out of 7. I've gotten used to it. I just lie there and pray or do whatever, think about the day. So, okay, so moving on. So that's what we mean by that. An event is just a collection of results or outcomes from something, a procedure, an experiment. So for example, with the dice, I might be interested in even numbers. So like on that die back here, you could think, what's the probability of an even number? That's an event, an even number. And I think we can risk picking a random person for that one as well. So Dante, do you know what the probability of getting an even number on a die is? So the numbers on a die are 1, 2, 3, 4, 5, 6. So of those 6, 3, 6, yes, very good. So 3, you're probably like me, haven't had the proper amount of caffeine, so still waking up. I'm with you, man. Okay, so that's what's meant by an event. And then a sample space is a list of all the different outcomes that can't be broken down any further. So on that die, the sample space is exactly what I just recited to Dante. So 1, 2, 3, 4, 5, and 6. So using that, what I want to do is I want to just for a brief moment focus on the idea of sample space. And so I've got some questions for you. What are the sample spaces for these random phenomena? So roll a 12-sided die. Ask a randomly chosen person how many children he or she has had. That's a random phenomena. Draw a card from a standard deck of cards and record its face value. What I mean there is like, is it an ace, two, three, four? You get the picture. And then finally, flip three coins, a penny, a dime, and a quarter, and record the orientation of the three. Take a minute, work with a friend, come up with a list. Each one of these will be a list of possible outcomes, just like this list. Usually mathematicians like to put these in curly brackets, but you don't have to. So take a minute, see if you can do that, and then I'll pick some volunteers to try to answer this. Oh, what? Oh no, sorry. I'm I'm just messing around up here. I'll try to. Okay, good. Where am I? There we go. Yeah, if you want to. Yeah. I, you will, but probably most people won't, and that's totally fine. Mm. Well, things have started to quiet down. So let's go ahead and see how you did with these. So we'll start with the 12-sided die. I should have had a picture like this up here earlier. That's what a 12-sided die looks like. It has, well, let's see. Abby Larkin, what do you think the sample space for a 12-sided die is? Yeah, very nice. most most of the time when I ask that question, they don't you don't the student doesn't go the distance. So I appreciate your sticking with it. I'm not even going to go the distance up here. Very nice. All right. So yeah, the numbers 1 through 12, you can't see them all on this die, but you see the 12 there. It's just printed by the numbers 1 through 12. Very nice. All right. So next, ask a randomly chosen person how many children he or she has had. Oz, what do you think of that one? Okay, well let's get started with this one. What are the numbers going to look like? Okay, and then you're like, oh, I don't know. Okay, very nice. So I appreciate Oz bringing up the Did you happen to know that particular world record? So you just happen to know that. Okay, very nice. I actually looked it up. Uh, Now I'm hesitant to show this to you because Oz has already. Well, okay. Um, no. It's only because the number you don't have the number right. So, uh, no. Uh, but it's okay. It's no shade on Oz. I didn't know if you looked it up right now or what. But here I've got it right here. Is I thought it'd be fun for you to guess, so you can guess too, Oz. Uh, which one of these, according to Guinness's Book of World Records? So take a minute. Is it 31? So no one's going to guess 31 now, um, but anyway, yeah. So let's look this up. And actually, Oz's statement is actually what is printed in the Guinness's. It's like you've memorized it or something. So I'm really impressed. But here it is. This is the Guinness's Book of World Records. The greatest, the largest number is 69 actually. So it's close. But you're right. It was 27 confinements, meaning 27 birth events, and there are 16 pairs of twins, 7 sets of triplets, and 4 sets of quadruplets. That's incredible. And the thing that really boggles my mind is that only two of these babies failed to survive infancy, which means she had to diaper and raise and feed 67 kids. It's incredible. And her name isn't even recorded. It's just her husband, of course, because we're misogynistic or whatever. But yeah, and then yeah, it's like you. So Oz had it right, like in polygamous countries. Who knows? The sky's the limit, apparently. Yeah. So this is, I guess, from the 19. That's the 1994 is the book that I have. No one has an actual book now, do you? You just look it up online. But anyway, I don't think that anyone has gotten beyond 69 in the intervening years. Okay, so we've got that out of the way. We'll get to the number 4 in a minute. Let's see who gets to do the face card. Um, Sienna, how would you describe number 3, the drawing of a card from a standard deck of cards? Like, what kind of cards could you get? Can you imagine? I don't have my cards with me, but I give you a card. What could it be? There are 13, but what are they? There you go. Yeah, you don't have to list them all off. I won't make it. But yeah, that's it. So it's just the different things: ace, 2, 3, 4, 5, etc. And then you get up to 10, jack, queen, and king. Um, unless I guess some people have a problem with face cards, so you'd have a rook deck, so you could use those instead. And then just to make where is it? To make Hayden happy, we can put Joker as a possibility there. So I don't care. I mean, the Joker thing would change the probabilities if we were to use it for probability, but one more. And so this one is interesting because I get all sorts of answers to this when I ask this question on quizzes and tests. Hint, hint, I usually ask this question on quizzes and tests. And so take a guess. I've got the most popular answers when I ask these up here. So see if you can figure out which is the correct one. Take a minute, take your guess. So here's the way to think about this. We have a penny, a dime, and a quarter, and we look at the penny, it's either heads or tails. So that's easy enough. The penny is either heads or tails. But then you throw the dime in there and you're like, well, the dime could be either heads or tails. So the penny could be heads and the dime could be heads, or the penny could be heads and the dime could be tails. Tails, heads, tails, tails. You have all of those different options. And then when you throw the quarter into the mix, it could be heads, 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 tails, heads, and you can sort of see that the correct answer now is letter E. So that lists all the possibilities. There are 8 possibilities for this particular random phenomenon. All right, so yeah, well, like I said, yeah, that's one of the possibilities. So we've already talked about how to compute probabilities. I think you've done this back in 7th grade, probably. But we might as well just practice this really quick. Yeah. I guess that if you're yeah, once is sufficient for me. The Joker is the problem because there are usually just 2 Jokers per deck. So if we were going to include the jokers, yes, we would want to write everyone 4 times. I don't want to do that, so I'm going to get rid of the joker. Yeah, because there's an even number, so essentially each one of those has the same chance. That's what we want. What do you think, Abby? Oh no, no, you just got to write about. So there's 8 of them. So yeah, it's not hard though. Yeah. By the way, having children is like flipping coins. If you think about it, when you have children, it's either a boy or a girl. And so you could have, if, like, for example, I have 3 children. I actually spoke with an alumnus on Saturday, had a nice phone call with him, and he has 3 children. I happen to have all girls. I've been blessed. And I usually tell people who, like, I know a couple other guys on campus who have 3 daughters. I say that God only gives 3 daughters to the strongest of men. This alumnus, the alumnus that I spoke to, he has 2 boys, and the youngest is a girl. So that's his family. But you can think of this as flipping coins. Either it's a boy or a girl. And my family, growing up, I was one of 3 children. I was in this family, girl, boy, boy. So I had an older sister and a younger brother. And this dynamic is different from this. So these are different types of families. So it's like flipping coins. You would have 8 of them. So when I say that this question is on your quiz and your test, what I mean is that it's something like it, either this or having children. So you can do either way. You can just think through, like, what are all the different families? You can have 8 different, if you think about it, there are 8 different families. Just change the heads to girls and the tails to boys. And you've got all the different families that you could have. Yeah, what do you think, Hayden? Yes. Okay. Yeah. 1 0. Yeah. You go do binary. That's fine. Okay. Yeah. Let's not. Yeah. I don't want to go there. Okay. Okay. Let's do probabilities because we do need to get to the statistics you can use, and you want to know the chances that you're going to die during the next year. I have it. I have it here. You're gonna. Don't worry. Okay. So roll a 12-sided die. I want to know the probability of getting a 7. There's 1 7 on a 12-sided die over 12. Nice and easy. Okay, draw a card from a standard deck of cards and record its face value. So I want to know the probability of an ace. Either we're going to say it's 1 out of 13 if we're going to do the way that I did this back here with the ace through king. Or if you're like Autumn and you want to list off all 52 cards, you would say, well, there are 4 aces out of 52 cards, which is the same, by the way. So either way you do it, it's going to be fine. But there will be a slight difference if you're Hayden and insist on including the jokers. So then it would be 4 out of 54 because of the 2 jokers. But either way, you're fine. Now let's deal with this last one. The last one's kind of interesting because this is also the probability of having 2 girls or the probability of having 2 boys. So going back to this sample space at the bottom, I want to know the probability of having exactly 2 heads. I should have specified exactly 2 heads. So look through that list if you can see it. Okay, this may be in the way. I apologize if it is, but look through the list and figure out how many ways can you have exactly 2 heads. Take a minute, count them up, and then we'll get the answer here in just a second. Anna, you can see that. Did you count the number of ways? There are 3, yeah. You can see them. They're right here. 1, 2, 3. 3 ways of having exactly 2 heads. And so the probability of having exactly 2 heads is actually 3 out of 8. So it's kind of interesting. Okay, so let's see. We have a few things before we get to the good stuff here. So one of the things that to note is this idea, this, you don't have to write this down, it's just a conceptual thing that helps us bridge the gap between probability and statistics. The reason, well, there's a good reason why we're interested in probability here. I'll show you in just a sec. But the law of large numbers allows us to bridge that gap. You know, we have these theoretical probabilities, but in statistics, we're doing something over and over again. We're asking people a question. You know, how do you feel about the current president? How do you feel? How do you feel? How do you? and that sort of thing. So these surveys and polls that we do over and over again is an example of a statistic. Probability comes into play when you think of doing this over and over again many, many times. When you do something many times, then the relative frequency, that is what we observe, tends to get close to the actual theoretical probability. If you flip a coin flip a coin 2 times, it would be unusual. Well, not that unusual, but it would be unusual to have one head, one tail. If you flip a coin, what's it? Okay, it's a half chance, okay? Whatever. Okay, flip it 4 times. How's that? Flip it 4 times, it's unusual to have exactly two, exactly two. But if you flip it 1,000 times, you're going to be pretty close to 500 and 500. And if you flip it 10,000 times, and there was a mathematician who was imprisoned during the World War II by the Nazis, and he actually flipped a coin, I think 20,000 times or so, and kept track of every single, maybe it was 10,000 times, kept track of every one of them and has recorded them. We have that record, and it was almost exactly 50-50. So I guess, if you're bored, that's what you do. So that's important for statistics. The other thing, why do we care, is that statistics is probability. So probability is used to make decisions for statistics. To illustrate this, I need to share with you some more statistics you can use. So this comes from this paper. It says the effects of acute increase in urge to void on cognitive functions in healthy adults. Now, if you don't know what all those words mean, I'll tell you. So here, this is a big problem, by the way, but this is too much fun for me not to share with you. Generally having such a small sample size would be frowned on, but I just love this, is they took 8 healthy young adults and had them drink 250 milliliters of water every 15 minutes until they could no longer hold it. So anyway, and then they did some performance tests, like give them some math problems to do. And wouldn't you know, if you have to go, it reduces your ability to do math. So that's all this says. So I think there's, sensations in the urge to void and pain increased with time, and having the extreme urge to void exerted a large negative effect on attentional and working memory functions. So if you're taking your test and you feel like you have to, just go, please. I mean, I've had students come and say, can I go to the rest? Yes, I want you to, because I don't want this to happen to you. By the way, here's the graph. So you can see that, I don't know exactly, let's see, the subjective rating, these are on a couple of tests that they did. Or actually, I don't know what this is, but something increased and then went back after you went to the bathroom. Okay, so here is why I wanted to show you this, is when you look at papers like this, you'll see something that, I don't know if you noticed this yet, but let me zoom in a bit. Something that shows up over and over again in the paper. I'll go show you the zoomed out version once I show you the zoomed in version. So I don't know if you're seeing what I'm seeing, but there's these P's. P is less than 0.001. So whenever you do statistics, you're always computing probabilities. The probabilities are the basis for the decisions. So back here, they say blah, 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 and then they say P is less than this, which is really impressive, by the way. You'll learn about this after spring break. And then there's another one of these P's over here. I guess that this is sort of a double entendre of sorts. But here, the P is greater than 0.05, and so on. By the way, just to balance this, there is a study that, do I have that here? Oh, I do. I just wanted to say that it's not always bad to like wait to go to the bathroom. And so here in this study, it turns out that if you have to go to the restroom badly, it actually dampens your urge to spend money. So if you go to Walmart, wait until after you've bought all the stuff before you go to the restroom instead of doing it before. Okay, so we have that. Now let's get the answers to those probability questions. Number 1, what is the probability that it's going to rain? I actually didn't prep this, so I'm going to have to look it up on my app. You probably have your own weather app. So let's see what it says here. Waiting. Daily. Chances of rain, 1%. 1% today, and it's probably, if it rains, it's more snow. Tomorrow, 24%, according to this. So you probably have your own little thing. So that would be the rain question. And that is, of course, based on empirical data. So you have meteorologists who have observed the world and they say, based on the conditions today, we've seen this before, similar conditions produce rain very infrequently. And so they say 1%. Getting an A, you probably have your own assessment of your own abilities and skills and your own, I think anyone here could get an A if you try hard enough, I guess, or come see me. If you bug me in my office at 6:30, you're probably going to be doing better than you would if you didn't. But anyway, this is based on 2 years worth of data from students. So 2 years of me teaching this class, 49 of those students got A's out of 211, which is not bad. What's that, about one little less than 1/4? So there's that. Powerball lottery. So this is actually a little bit old because I don't know what the lottery is these days. It's always going to be like this, though. Oh, that should be an equal sign there. Is that if you were to look at the lottery, and this is actually a theoretical probability, the Powerball lottery at least, there are this many ways of picking your numbers. And so one way of winning out of that many ways of picking your numbers. Now, if you're interested in whatever lottery, I don't know what the lottery is these days, Mega Millions, whatever it is. Anyway, we could do that one as well later. Come to my office. But anyway, the chances of this happening is incredibly small. What's this? 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then an 8. So very low chance of winning the lottery. So I don't recommend it. Not only that, but I have problems with it being like a tax on the poor, for example, or stupid person tax. That's so mean of me, but anyway, yeah, it's not good. It's a bad thing. But anyway, getting back to this, so you might ask, what's your probability of dying during the next year? That was the last of the questions. On the CDC website, there are these so-called life tables, and on those life tables, you can look up your gender, your race. So different races have different life expectancies and so forth. This is just the collective. So if you really want to know, you're going to have to look this up yourself on the CDC. There are tables after tables. But I downloaded the tables, and this is the most recent one. You can look up your age and your gender to figure out your probability of dying. So I think I probably have all of your ages here. And down here, back when I made this table the first time, I was 50. I'm no longer. I've updated it on the next slide. So if you really want to know what your chances of dying are, it's actually quite a bit better than you winning the lottery. I mean, look at these guys in their 20s. I mean, if you're in your 20s, guys, this is a dangerous time of life for you. 0.001, that's 1 in 1,000. That means if there are 1,000 of you running around, one of you is going to be dead next year, according to the CDC. I know, but now spare a thought, though. Spare a thought for the 56-year-olds. So here I've updated this. Down at the bottom, you can see that my chances are a little bit better than yours. 1 in 100. So kind of put some perspective on things. Yeah, by the way, this number here is life expectancy from this point in time. So I guess I can expect to live another 23 or so years if everything goes well. So what does that put me at, 79? I'd be actually quite happy if I made it to 79. My mom and dad both died at 78. And so I always took that as being the target. By the way, an interesting question about these tables is you might wonder, who is the safest person in the United States? So the safest person, you can take your guess, but here I actually have, this is from 2011, and then I'll show you currently what the graph looks like. I like the 2011 graph better. So these are the probabilities of dying, graphed according to age. The red is the female, the blue is the male. Now, I just want to explain this hump here. So first of all, though, the safest person in the United States is an 11-year-old boy. So you can see down here, 11-year-old boy is a little bit lower chance of dying than 11-year-old girl. Yeah, being an infant is really dangerous. But then notice what happens to that 11-year-old boy right around here. that stupidity gene kicks in, and suddenly they get a car and they have all sorts of access to dangerous things, and then they realize how stupid those things are, and then but we never get back to where the women are. By the way, yeah, this is from 2011. Because they produce these tables every 10 years around census time. That's why it's every decade. Um, uh, I was interested when this happened. This interested me because in 2001, the safest person to be was a 10-year-old girl. So it switched. The boys, I think, because instead of climbing trees, they were just playing video games, and it was the girls who, my girls did all. I have a picture of one of my girls at the top of this pine tree. It's swaying back and anyway. So here is a comparison if you want to see it. This is 2001. Here are the probabilities. So you can see the girls were lower chance of dying. You still had that stupidity gene. And then here's 2011. And an interesting thing happened in 2021. It's like we never recovered. You know, you can see, guys. So this is a challenge to you guys. Is you need to settle down, like bring it back. If you can survive your 20s, you need to pull it back a notch. But it looks like everyone, all these guys are still saying, "Hey, guys, watch this," and you know those are famous last words. So you know, do your best, guys. We need to bring it back a bit because things are getting worse for us. So, okay, so that's it. If you want to stick around and chat, feel free. Otherwise, we'll see.